Picture yourself standing in the middle of a vast, sun-scorched desert. The heat shimmers above endless dunes that roll toward the horizon. In every direction, a landscape that seems utterly lifeless, timeless, and unchanging. But what if I told you that right beneath your feet lies an entire world that has vanished from sight? A world not of sand and stone, but of water, life, and forgotten civilizations. What you're walking on isn't just a desert, it's a disguise, a mask worn by the earth to hide one of its most astonishing secrets. For centuries, deserts have been misunderstood as barren, empty places. But today, we know they are something far more extraordinary. They are living archives. Beneath those rolling dunes and dry riverbeds are the remnants of ancient lakes, sprawling river systems, and even entire ecosystems that flourished when the climate was wetter, kinder, and full of life. This is the incredible story of Earth's deserts, not as wastelands, but as keepers of deep time. They hold clues to some of the most dramatic turning points in our planet's history, periods of climatic upheaval, the rise and fall of ancient societies, and the relentless, beautiful cycles of nature that continue to shape our world today. In this video, we're going on a journey to uncover these hidden worlds, from the Sahara where giraffes once roamed and great rivers flowed to the deserts of Arabia, which served as green corridors for early human migration. We'll explore how shifting climates and geological forces buried these aquatic landscapes under the sand. We'll look at the science behind these transformations, hear the stories of the people who adapted to them, and discover why understanding these ancient changes is more relevant now than ever. So come with me, let's pull back the curtain of sand together and explore the flooded worlds hiding in plain sight. You'll never see a desert the same way again. It's almost impossible to picture today, but if we could rewind the clock just 5,000 years, the view from the same spot would be utterly unrecognizable. Instead of an ocean of sand, you'd be standing in a vast, grassy savanna. Herds of elephants and buffalo would be grazing near the shores of sprawling freshwater lakes. Hippos would be wallowing in rivers wide enough to be navigated by boat, and early human fishermen would be casting nets into waters teeming with life. This was the Sahara during what scientists call the African Humid period, a time when North Africa was not a desert at all, but a lush green paradise. This incredible transformation began around 11,000 years ago, triggered by a slight wobble in Earth's orbit. These predictable orbital shifts, known as Milankovitch cycles, gradually changed the amount of sunlight reaching different parts of the planet. For North Africa, this meant the monsoon belts moved farther north, bringing torrential seasonal rains for millennia. The land responded explosively. Seeds that had lain dormant in the soil for thousands of years suddenly sprouted, creating a carpet of grasses and acacia trees that supported a stunning diversity of wildlife. This wasn't a minor ecological change, it was a complete continental makeover. We don't have to just imagine this lost world, we can actually see it. The most breathtaking evidence comes from the cave and rock art left behind by the people who thrived there. In the high plateau of Tassili Ennaja in modern-day Algeria, the sandstone walls are a vast open-air gallery depicting this vanished life. There are detailed paintings of people swimming, of cattle herders tending their large herds, and of hunters pursuing giraffes, antelopes, and animals that have no business being in a desert. These artworks are not mere imagination. They are a direct historical record, a postcard from a time when the Sahara was a land of plenty. modern science allows us to map this green Sahara with astonishing precision. By analyzing deep sediment cores drilled from ocean floors and ancient lakebeds, paleoclimatologists can read the layers of pollen and fossils like pages in a book, reconstructing the ecosystem year by year. Satellite radar technology has peered through the dry sand to reveal the ghostly outlines of massive river systems that once flowed across the entire region. One of the largest, the Tamanrasset River, is believed to have been even bigger than the Amazon, carving a valley now buried under the dunes of Mauritania and flowing all the way into the Atlantic Ocean. This cycle of greening and desertification has happened multiple times over hundreds of thousands of years. The Sahara acts as a giant mirror reflecting small changes in Earth's climate, dramatically flipping between wet and dry states. This volatility forced the humans living there to become incredibly resilient and innovative. One of the most sophisticated civilizations to emerge from this environment was the Garamantes, who built their kingdom in what is now Libya long after the region had begun to dry out. They couldn't rely on surface rivers anymore, so they became masters of the deep earth. They engineered a complex system of underground tunnels called fogaras to tap into ancient fossil water reserves trapped deep in the aquifer, creating a network of oases that sustained their cities for centuries. Their story is a powerful reminder that the ground beneath our feet holds memories of climates and worlds that are long gone. The Sahara's secret, that it was once a land of lakes and rivers, completely reshapes our understanding of what a desert is. It's not a static, dead place, but a landscape with a dynamic and dramatic history capable of profound change. And if the greatest desert on Earth can hide such a watery past, what other astonishing secrets are waiting to be uncovered beneath the sands of other arid lands? But the story of a green Arabia isn't just about ancient lakes and animals. It's a fundamental chapter in the story of us. This newly hospitable landscape became a crucial superhighway for early human migration. For a long time, scientists believed that our ancestors, Homo sapiens, were confined to Africa for millennia, only making a major exodus around 60,000 years ago via the Nile Valley or the narrow Bab el-Mandeb Strait. But the discovery of these green phases in Arabia has completely rewritten that narrative. Sites like Jebel Faya in the United Arab Emirates have yielded stone tools that are over 100,000 years old, tools that are unmistakably the work of modern humans. This evidence suggests that during one of these early humid periods, small groups of people walked out of Africa and into a green and welcoming Arabia, not a barren desert. They found a land crisscrossed with rivers and dotted with lakes, a place where they could hunt, gather, and survive. This means human dispersal out of Africa happened much earlier and through a much wider corridor than we ever thought possible. These early pioneers wouldn't have been alone for long. The same lakes that attracted humans also drew other animals from Africa, creating a familiar ecosystem that made the journey less daunting. As the climate shifted again and the deserts began to reclaim the land, these populations faced a critical choice: adapt to the increasing aridity, retreat back to Africa, or move forward. Many likely followed the retreating water sources, their migration paths effectively funneled by the changing environment. This movement wasn't a single, organized event but a series of pulses, each tied to the rhythm of the Arabian climate. It was a stop-and-start journey across generations, with each green phase opening a new window of opportunity for exploration and settlement. This incredible adaptability in the face of a fluctuating climate is a testament to human resilience and is key to understanding how we eventually came to populate every corner of the globe. The work of experts like Professor Adrian Parker has been instrumental in piecing this story together. By analyzing paleoenvironmental data, such as ancient pollen grains preserved in lakebed sediments and the mineral deposits that form in specific climatic conditions, researchers can reconstruct the Arabian landscape with remarkable detail. They can tell us not just that it was wetter, but what types of plants grew there, how seasonal the rainfall was, and how quickly the environment changed. Their findings point to a disturbing pattern of abrupt climate shifts. The transition from green paradise to harsh desert didn't always happen over thousands of years. Sometimes it could occur within just a few centuries, a blink of an eye in geological terms. For the people and animals living there, this would have been a catastrophic and undeniable crisis, forcing rapid adaptation or triggering mass migrations that reshaped the human map of the ancient world. This narrative of a lost green Arabia, filled with life and then lost to the sands, forces us to reconsider the very nature of deserts. They are not permanent, fixed barriers but dynamic, ever-changing landscapes that have pulsed with life and then fallen silent multiple times throughout Earth's history. The empty quarter is only empty now. Its past is crowded with stories of survival, movement, and connection. The secrets buried beneath its sands don't just tell us about ancient climates, they speak directly to the deepest questions of human prehistory, where we came from and how we managed to traverse a planet that was constantly changing around us. It reminds us that the presence or absence of a single resource, water, has always been the most powerful force in shaping human destiny, determining the routes of our ancestors and the rise and fall of the worlds they built. So how exactly does a landscape of wind and sand become a perfect time capsule for water? The answer lies in the very nature of deserts themselves. Without dense vegetation or heavy rainfall to constantly erode the surface, the clues left behind by ancient rivers, lakes, and seas aren't washed away. Instead, they are gently buried and exquisitely preserved under layers of sand and sediment, waiting for a trained eye to read their story. Deserts are essentially nature's museums, and their collections are made of stone, mineral, and dust. Take a walk through the Namib Desert along the coast of southwestern Africa, and you might notice something strange scattered among the towering orange dunes, vast, white, crusty deposits of gypsum. This mineral typically forms when bodies of water evaporate under a hot sun, leaving their dissolved chemicals behind to crystallize. The presence of so much gypsum here is a dead giveaway. It's a chemical ghost, a permanent stain on the landscape that marks the spot where a vast inland sea once covered the land millions of years ago. In some areas, you can even find the faint, wave-cut terraces of ancient shorelines, like bathtub rings on a continental scale, silently testifying to a time when the ocean reached much farther inland. To unravel the timeline of these incredible transformations, geologists become detectives of deep time. They use a powerful combination of techniques to piece the story together. Stratigraphy allows them to read the sequence of sedimentary layers, much like reading the pages of a book from bottom to top. A layer of fossilized fish bones sitting atop a bed of river gravel and buried under a thick blanket of sand tells a clear story of a flowing river that expanded into a lake teeming with life before eventually being choked off by dunes. To put exact dates on these chapters, scientists turn to radiometric dating. By measuring the decay of specific radioactive elements within rocks and minerals, they can pinpoint when a layer was formed or buried, creating a precise chronological narrative of the desert's watery past. Perhaps one of the most striking places to see this evidence is in the Great Salt Flats of the world, like the Chott El Djerid in Tunisia. This massive, blindingly white expanse looks like an alien landscape, but it was once part of a much larger system of lakes that dominated North Africa. These chots are what geologists call evaporite deposits. They formed when the last remnants of those great lakes finally dried up, leaving behind a thick crust of salt and other minerals that had been dissolved in the water for millennia. Standing on that cracked, salty surface is literally standing on the dried-out bottom of an ancient lake. The sheer scale of it forces you to contemplate the volume of water that must have once been there. The process of preservation is a delicate dance between sedimentation and erosion. When a desert has a wet phase, rivers flow carrying sand, silt, and clay. They deposit these sediments in their channels, on their floodplains, and at the bottoms of lakes. When the climate dries out and the rivers vanish, these layered sediments are left exposed. Instead of being washed away by rain, they are slowly and gently buried by wind-blown sand. This protective blanket of dunes shields the delicate layers beneath from destruction. Then, much later, when the wind shifts direction again, it can scour away the sand, re-exposing those ancient riverbeds and lake bottoms exactly as they were left, frozen in time. In the American Southwest, the evidence is written in the mud. Vast, flat desert plains known as playas are the remnants of prehistoric lakes. When these playas get a rare rain, they briefly turn into shallow ponds. As they dry out again, the thick clay mud cracks into intricate hexagonal patterns called desiccation cracks. These aren't just temporary features, they can be buried and preserved. Geologists find these exact same crack patterns in solid rock formations that are millions of years old, providing a stunningly clear and immediate connection to a moment when that same spot was the muddy shore of a vanishing lake. It's a snapshot of a specific day of drought from an ancient world. By meticulously studying all of these features, the mineral deposits, the sedimentary layers, the fossilized cracks, scientists can do more than just confirm that water was once present. They can reconstruct the entire paleoclimate. They can determine if an ancient lake was deep and permanent or shallow and seasonal. They can deduce the temperature and chemistry of the water, and by extension, the composition of the atmosphere at the time. This turns deserts into incredibly valuable barometers for past climate change, offering us a library of real-world examples of how our planet responds to shifts in temperature and precipitation. These silent stones and sands don't just speak of forgotten oceans. They whisper detailed secrets about the ancient atmosphere that surrounded them, providing crucial data for understanding our climate future. While the geological clues on the surface tell a compelling story, the most astonishing revelations about deserts' watery pasts have come from a perspective high above the Earth. We no longer need to rely solely on the slow, painstaking work of digging in the sand. Today, we have an array of orbital eyes that can map these hidden worlds from space, seeing straight through the desert's dry disguise. This isn't science fiction, it's the cutting-edge field of remote sensing, where satellites equipped with advanced radar, infrared, and gravity measuring technology are rewriting the maps of ancient history. The principle behind this technology is as brilliant as it is simple. Different materials reflect and absorb energy in unique ways, creating signatures that sensors can detect from hundreds of miles away. For instance, subsurface water or buried river channels filled with sediment will have a different density and moisture content than the surrounding dry sand. Satellites using synthetic aperture radar, or SAR, can send down microwave pulses that penetrate the dry surface layer and bounce off these hidden features, measuring the subtle differences in the return signal to create a detailed picture of what lies beneath. It's like giving the entire desert a sophisticated ultrasound, revealing structures completely invisible to the naked eye. One of the most groundbreaking missions in this effort is NASA GRACE, which stands for Gravity Recovery and Climate Experiment. This mission took a completely different approach. Instead of looking at the surface, it measured tiny changes in Earth's gravitational field. How does this relate to water? Because water has mass, and large concentrations of it, like those trapped in massive underground aquifers, exert a slightly stronger gravitational pull. By tracking these minuscule gravitational variations over time with exquisite precision, the twin Grace satellites were able to literally weigh the water hidden beneath the Sahara. What they found was staggering: vast reservoirs of fossil water, known as the Nubian Sandstone Aquifer System, containing enough water to fill Lake Erie many times over. This is not recent rainwater, it's a prehistoric resource trapped in porous rock for thousands of years, a relic of those ancient green periods. The impact of this technology on archaeology has been equally profound. In Egypt, satellite infrared imagery has been used to identify a sprawling network of buried river channels and tributaries running parallel to the Nile. Pioneering this work, Dr. Farouk El-Baz, a renowned Egyptian space scientist, proposed the concept of radar rivers. He theorized that during earlier humid periods, a vast network of rivers, which he named the Kafra, once flowed across what is now Libya and Egypt, long before the Nile established its current course. Satellite data confirmed his theory, mapping the paleo-drainage patterns of this lost river system beneath the Sahara's sands. This discovery didn't just solve a geological mystery, it provided a new template for understanding human settlement. Suddenly, archaeologists knew exactly where to look for the remains of ancient campsites and settlements, not in the barren desert of today, but along the ghost banks of these vanished waterways. These satellite revelations are far more than just academic exercises. They have urgent, real-world applications in the present day. For nations struggling with water scarcity, the detailed maps of fossil aquifers provide a crucial guide for sustainable resource management. They show the extent, depth, and volume of these non-renewable water supplies, allowing governments to plan their extraction carefully to avoid depletion. Furthermore, identifying ancient river channels and lake beds helps in locating the best spots for modern well digging or for managed aquifer recharge projects, where excess surface water is directed back into the ground to replenish these ancient stores. The same technology that finds lost civilizations can also help save existing ones, as we continue to point these sophisticated instruments at the world's deserts. Who knows what other secrets will come to light? Will we find the definitive location of a legendary lost city, or map a completely unknown prehistoric mega-lake? Each pass of a satellite overhead adds another layer of data to our understanding, peeling back the desert's layers without ever disturbing a single grain of sand. This high-tech exploration beautifully bridges the deepest past with the most pressing present, proving that the stories buried beneath the dunes are not just about where we've been, but are absolutely critical to determining where we're going. This incredible dynamism, this constant state of flux, is the true nature of Earth's deserts. They are not frozen in time. They are living, breathing landscapes that have expanded and contracted for millions of years, their borders shifting in a slow dance with the planet's climate. To understand their past and predict their future, we need to look beyond the sand and into the very engines of global climate that drive these monumental changes. The forces that turned the Sahara green and then sealed its fate are the same ones we are influencing today, making the study of ancient desert transformation a critically urgent field. To grasp the scale of these changes, we can look back to a period known as the last glacial maximum, around 20,000 years ago. The world was a very different place then. Vast ice sheets covered much of North America and Europe, locking away enormous volumes of water. This caused global sea levels to plummet, exposing continental shelves and connecting landmasses that are now separate. But it wasn't just the coastlines that were affected. The entire planet's atmospheric circulation was altered. With so much of the world's water frozen, the air was drier and wind patterns shifted. For some deserts, this meant even more intense aridity, but for others, like the American Southwest, it actually brought more rain. The now dry basins of lakes like Bonneville, which once covered a huge part of Utah, were filled to the brim during this cooler, wetter phase. This paradox shows that desertification isn't a simple one-way street toward dryness. It's a complex response to a constantly changing global system. So what are the primary levers that control this system? Scientists have identified several key players through painstaking research. The first is greenhouse gas concentrations. By analyzing tiny air bubbles trapped in ancient ice cores drilled from Antarctica and Greenland, climatologists can measure the exact level of carbon dioxide and methane in the atmosphere going back hundreds of thousands of years. They've found a stunningly consistent correlation. When CO2 levels are low, as they were during ice ages, the world is generally cooler and drier, and many deserts expand. When CO2 levels rise, temperatures follow, and precipitation patterns shift dramatically, often greening certain arid regions. Then there are ocean currents, the great conveyor belts of heat and moisture that circulate around the globe. Events like El Niño in the Pacific can trigger devastating droughts in places like Australia and floods in South America, showing how interconnected desert climates are with distant seas. Finally, massive volcanic eruptions can inject so much ash and sulfur dioxide into the upper atmosphere that they temporarily shield the Earth from the sun, causing short-term global cooling that can disrupt rainfall patterns for years. The end of the African humid period, around 5,000 years ago, is a perfect case study of these forces in action. The orbital cycles that had brought monsoons to the Sahara were gradually shifting again, reducing the intensity of the seasonal rains. But evidence suggests that this natural drying trend may have been accelerated by the very humans who thrived there, as proposed by archaeologists like Dr. David Wright. The proliferation of livestock, goats, sheep, and cattle led to overgrazing. As the animals consumed the vegetation that anchored the soil, the ground's albedo or reflectivity changed. The bright, bare sand reflected more sunlight back into the atmosphere, which in turn weakened the thermal low-pressure systems that draw in monsoon rains. This created a vicious feedback loop. Less rain led to less plant life, which led to more reflective sand, which led to even less rain. It's a powerful example of how small, localized human activities can potentially tip a delicate environmental balance and contribute to a large-scale climate shift. This deep history provides a crucial context for the changes we are witnessing today. Modern anthropogenic climate change, driven by our unprecedented emission of greenhouse gases, is acting as a powerful new force on this ancient system. The big question scientists are now trying to answer is, how will it affect the world's deserts? The answers are complex and region-specific. In some areas, like the Sahel region just south of the Sahara, satellite data has already shown a phenomenon called greening, with increased rainfall and vegetation cover over recent decades. Some climate models predict this could continue as a warmer atmosphere holds more moisture. However, this potential benefit is wildly unpredictable and could be offset by more frequent and severe droughts. In other regions, like the American Southwest, the forecast is particularly grim. Higher temperatures are leading to increased evaporation, more intense droughts, and a phenomenon known as aridification, a long-term, permanent drying of the land that goes beyond temporary drought. The past teaches us that deserts are exquisitely sensitive to change, and the changes we are making now are happening at a speed that may far exceed their natural capacity to adapt. Perhaps the most stunning testament to human ingenuity in the face of a drying world is found not in grand monuments but deep underground. In the heart of the Sahara, the Garamante Civilization faced a crisis. The savannas were retreating, the surface lakes were evaporating, and the world they knew was literally turning to dust. But instead of abandoning their land, they looked down. They discovered that beneath the desiccated surface lay a treasure, vast reservoirs of fossil water, rainfall that had seeped into the aquifer thousands of years earlier during the Green Sahara period. Tapping this resource required brilliance, and they delivered. They engineered an extensive network of underground tunnels known as fagaras. These weren't simple wells, they were gently sloping subterranean channels, sometimes stretching for miles, that used gravity to draw water from the aquifer and deliver it directly to their fields and settlements. It was a complex, labor-intensive system of shafts and tunnels that had to be meticulously maintained, but it worked spectacularly. This ingenuity transformed their capital, Jerma, from a struggling outpost into a flourishing hub of agriculture and trade, a verdant island in an increasingly hostile sea of sand. Half a world away, in the rocky canyons of what is now Jordan, another civilization was performing a different kind of water magic. The Nabateans chose to build their spectacular city of Petra in a place that received scarce and unpredictable rainfall. Their genius wasn't in tapping underground water, but in capturing every single drop that fell from the sky. They sculpted the entire landscape into a massive water collection system. They constructed an intricate network of dams and diversion channels to control flash floods, directing the torrential water into vast, cunningly hidden cisterns carved directly into the rose-red cliff faces. They lined these reservoirs with special plaster to prevent seepage, creating a reliable municipal water supply that could support a population of tens of thousands. This mastery of hydraulics allowed them to not just survive, but to create a wealthy, powerful kingdom that controlled trade routes and dazzled visitors with its fountains and gardens, all in the middle of a desert. The archaeological record leaves us in no doubt about the success of these adaptations. Excavations at Garamante sites yield not just the remains of their fagaras, but also pottery fragments that once held water and grain, stone tools used for farming, and the foundations of permanent settlements that indicate a shift from nomadic pastoralism to a settled agricultural life. In Petra, the evidence is even more dramatic. Intricate terracotta pipes that formed a pressurized water system for elite homes, and inscriptions detailing water rights and management, proof of a highly organized society built around the precise control of its most precious resource. These artifacts are more than just historical curiosities. They are tangible proof of humanity's ability to innovate under pressure. This deep history is more than a fascinating story. It's a source of vital lessons. As modern expert Professor Andrew Wilson points out, these ancient systems were fundamentally sustainable. The Garamantes fagaras minimized evaporation loss, a critical advantage in a dry climate, while the Nabateans' focus on rainwater harvesting worked in harmony with the natural water cycle rather than depleting finite groundwater reserves. Their strategies were born of a deep, intimate understanding of their local environment, a knowledge that we, with our reliance on energy-intensive solutions like massive desalination plants, sometimes overlook. They teach us the principles of resilience, the value of decentralized systems, the importance of community management, and the critical need to design our water infrastructure around conservation from the very beginning. We can also trace this cultural evolution through the art they left behind. The rock art of the Sahara shows a clear progression. Early paintings depict scenes of hunting large game like giraffes and elephants, a testament to the lush, green world of the Humid period. Later images show domesticated cattle and herding scenes, marking the shift to pastoralism as the climate began to dry. The latest inscriptions often focus on camels and trade caravans, illustrating the final adaptation to full desert life and the economic strategies that emerged in response. This artistic timeline is a powerful narrative of human flexibility, a visual diary of a people constantly recalibrating their relationship with a changing world, moving from hunting to herding to building sophisticated hydraulic civilizations. Their legacy is a powerful invitation to look to the past for inspiration, to blend ancient wisdom with modern technology as we face our own era of environmental volatility. Buried deep beneath the arid surface of the world's great deserts lies a treasure more valuable than any gem or mineral, water. But this is not the rainwater of a passing storm or a seasonal river. This is fossil water, an ancient relic from a completely different climatic era, sealed away for millennia in massive underground vaults of rock and sand. These vast subterranean reservoirs are the ghostly remains of those lush green periods we've been exploring, the final hidden chapter of a world that vanished from the surface long ago. They are, in a very real sense, bottled time. The formation of these aquifers is a slow-motion miracle of geology. Picture the green Sahara during its last humid period, around 10,000 years ago. Torrential monsoon rains would fall, and rather than simply pooling on the surface or immediately evaporating under the hot sun, a significant portion of this precious freshwater would begin a long, slow journey downward. It would percolate through the soil, through layers of porous sandstone and gravel, filtering deeper and deeper into the earth. Over centuries, this water migrated down through the rock layers until it reached a depth where it was trapped by a seal of impermeable rock like clay or shale. There it settled, drop by drop, century by century, cut off from the atmosphere and the water cycle above. It became a time capsule, isolated and preserved, its chemical signature frozen in time from the moment it first seeped into the ground. To understand just how old this water is, scientists turn to a powerful form of detective work called isotopic dating. Water molecules are made of hydrogen and oxygen, and some of these atoms are slightly heavier isotopes, like deuterium or oxygen-18. The ratio of these isotopes in water changes over time based on specific environmental conditions, acting like a unique fingerprint for the climate when the water fell as rain. By analyzing these ratios, hydrologists can determine the water's age. The results are staggering. In the Nubian sandstone aquifer system beneath the eastern Sahara, one of the largest fossil aquifers in the world, much of the water is between 10,000 and 1 million years old. This means the water we might pump to the surface today for irrigation fell as rain when woolly mammoths still roamed parts of the earth and early humans were just beginning to form settled communities. We are quite literally mining the rainfall of the Ice Age. The sheer scale of these hidden resources is almost incomprehensible. The Nubian aquifer alone is estimated to hold over 150,000 cubic kilometers of water. To put that in perspective, that's enough to cover the entire landmass of Germany in a layer of water over 300 meters deep. For nations like Libya, Egypt, Chad, and Sudan that sit above this vast reserve, it has been understandably tempting to tap into this seemingly endless supply to fuel agricultural development and support growing populations. The Great Man-Made River project in Libya, one of the most ambitious engineering endeavors in history, was built to do just that, a massive network of pipes designed to pump fossil water from the southern desert to coastal cities and farms. It stands as a monument to human ingenuity, but also to a critical dilemma because this water is not renewable. It is a finite resource, a one-time gift from a past climate. When it's pumped out, it is not being replenished by the scant rainfall of the current desert. Using it is like withdrawing money from a savings account that can never again receive a deposit. The consequences of over-extraction are severe and often irreversible. As the water table drops, the land above it can collapse, forming massive sinkholes that swallow everything on the surface. Furthermore, as the fresh water is drawn down, it can pull up ancient, highly saline water from even deeper rock layers, contaminating the entire aquifer and rendering the water useless for drinking or irrigation. This process, known as salinization, permanently ruins the resource. This is not a problem confined to the Sahara. A powerful case study exists in the heart of the United States, the Ogallala Aquifer. While not located under a classic desert, it lies beneath the high plains, a semi-arid region where rainfall is insufficient for large-scale agriculture. The Ogallala is also fossil water, filled during the wetter climates of the last ice age. Since the 1940s, center-pivot irrigation systems have tapped into the Ogallala, transforming the dusty plains into one of the world's most productive agricultural regions, often called America's breadbasket. But this boom has come at a tremendous cost. In many areas, the water table has dropped more than 150 feet, and some experts predict vast sections of the aquifer could be effectively exhausted within a few decades. The communities that depend on it are now facing the same difficult questions as those in North Africa. How do we transition from an economy built on a finite resource to one that is truly sustainable? Prominent hydrologists like Dr. Mohammed Sultan have been vocal advocates for a new approach. They argue for a shift from reckless extraction to meticulous, science-based management. This means implementing strict quotas on pumping, heavily investing in alternative water sources like desalination and advanced wastewater recycling, and a radical move towards water-efficient drip irrigation and crops that require less water. It's about treating fossil water not as a primary source for daily use, but as a strategic emergency reserve, a buffer to be used only during periods of extreme drought to prevent societal collapse. This taps into a profound ethical question that connects us directly to those ancient Garamantes. Do we have the right to use up this ancient legacy, this water from a different world, for our short-term benefit, knowing it will leave nothing for future generations? The choices we make today about these prehistoric treasures will echo for centuries, determining whether we are remembered as wise stewards or the generation that willfully drank the past dry. While the legendary city of Heracleion met its fate beneath the Mediterranean waves, a similar destiny played out in the heart of the desert, where not ocean water, but the relentless advance of sand and the retreat of life-giving lakes submerged entire communities. These lost cities of the arid world capture our imagination not because they vanished into the deep, but because they were slowly, deliberately swallowed by the very land they stood upon, their stories preserved in a dry tomb of dust. They are the silent witnesses to a terrifying truth, that a changing climate doesn't just alter the landscape, it can erase entire chapters of human history. Perhaps no lost city embodies this mystery more than Yuba, also known as Aram of the Pillars, a name steeped in the folklore of the Arabian Peninsula. For centuries, it was considered a mere legend, a fabled metropolis of immense wealth and towering structures mentioned in the Quran, and 1001 Nights, said to have been punished for its arrogance by being swallowed into the sands of the empty quarter. The story seemed like a classic moral tale until modern technology provided a way to separate myth from reality. In the 1980s and 90s, a team of archaeologists, including the indefatigable Dr. Joris Zarins, embarked on a quest to find the truth. They didn't rely on shovels and camels alone. They turned to the eyes in the sky. By analyzing radar images from the Space Shuttle Challenger, they were able to peer through the superficial layer of sand and identify ancient tracks, the fossilized pathways of long-vanished camel caravans. These trails, invisible on the surface, all converged on a single point in modern-day Oman, the site of Shisar. Guided by these satellite maps, the team began to excavate. What they uncovered was nothing short of extraordinary. The remains of a large fortified settlement centered around a massive limestone sinkhole. The ground-penetrating radar confirmed the presence of walls and rooms buried deep beneath the dunes. The evidence painted a vivid picture. Yuba was not a city punished by divine wrath, but a sophisticated hub of the frankincense trade that fell victim to its own environment. It was built over a vast cavern that served as a natural reservoir, a crucial water source in the desert. As the climate continued to dry and the water table dropped, the cavern's roof eventually collapsed, catastrophically consuming large portions of the city into the earth. The sands, driven by endless winds, did the rest, burying the ruins and transforming a thriving center of commerce into a whispered legend for 1,000 years. This pattern of a prosperous settlement undone by hydrological collapse is echoed far to the west in the Egyptian desert. Beyond the fertile strip of the Nile Valley, the western desert holds the haunting remains of outposts that once thrived on now vanished lakes. During a wetter phase, a large lake known as Lake Moeris existed in the Fayum Depression, supporting a thriving Neolithic culture. As the climate aridified and the lake shrunk, the communities that depended on it were forced to abandon their homes. Archaeologists exploring these sites find the poignant debris of sudden departure: grinding stones left beside hearths, pottery jars still standing where they were last placed, and tools scattered as if the owners intended to return any moment. These artifacts are not treasure in the traditional sense. They are frozen moments of human desperation, telling a story of adaptation that ultimately failed. They show us that the end of these communities wasn't always a dramatic, single event like Yuba's collapse, but often a slow, agonizing retreat in the face of a dying world. The work of uncovering these sites is a race against time and the elements. Every time the wind shifts, it can reveal a new artifact or bury a crucial clue forever. Technologies like LiDAR and ground-penetrating radar have become indispensable, allowing archaeologists to map entire buried city plans without moving a single grain of sand, preserving the context of objects that would be destroyed by traditional digging. Each discovery adds a piece to the puzzle. A child's toy found in a buried room in a Karga oasis settlement speaks to the daily life that once filled these spaces. Inscriptions on a pottery shard might mention a well running dry, directly linking the site's abandonment to the loss of water. What these lost cities and submerged ruins ultimately teach us is a profound lesson in human resilience and fragility. They were not failures, they were often magnificent successes that flourished for centuries by mastering their harsh environments. Their downfall came when the environmental rules of the game changed beyond their capacity to adapt. They stand as stark monuments to the intricate bond between human civilization and water security. Exploring their dust-choked streets is like reading a warning from the past, written not in words but in stone, bone, and the enduring silence of the sand. They force us to ask ourselves a difficult question. In our own era of rapid climate change, which of our great cities might future archaeologists one day be searching for, buried not under sand but under the rising sea? Long before satellites peered through the sand or geologists drilled into ancient lake beds, the people who called these harsh landscapes home were already keeping a record of their transformation. They didn't use scientific instruments or data charts. They used something far more powerful and enduring: story. Woven into the fabric of their cultures, passed down from elder to child around countless campfires, are myths and legends that echo with the memory of water. These are not mere fanciful tales. Many scholars now believe they are a form of deep-time oral history, a way for entire civilizations to preserve the traumatic and awe-inspiring memory of their world turning from green to gold, from wet to dry. Consider the Tuareg people, the legendary blue men of the Sahara. Their oral traditions are filled with poignant references to a time when the desert was not a desert at all. They speak of a land they call Tenere, which literally means desert in their language, but their stories describe it in a completely different light. They tell of a vast, grassy plain crisscrossed by flowing rivers where their ancestors hunted wild game and cattle roamed in great herds. They even have specific names for rivers that no longer exist, describing their courses and the communities that lived along their banks with a precision that is striking. For generations, these narratives were heard by outsiders as beautiful metaphors. But now, when placed alongside the geological evidence of the Green Sahara, they read less like fiction and more like a people's collective memoir of a lost homeland, an ecological truth preserved in poetry. This pattern repeats itself across the sand seas of Arabia. The story of Iram of the Pillars, also known as Yubar, is a cornerstone of Arabian folklore, immortalized in the Quran and 1001 Nights. It was described as a city of unparalleled wealth and hubris, a place of towering architecture built by a powerful tribe that grew corrupt. As punishment for turning away from righteousness, the legend says, the city was utterly destroyed, swallowed by a sandstorm, and erased from the earth. For centuries, it was the ultimate desert ghost story. Yet, as we explored earlier, archaeological work led by Dr. Juris Zarins suggests a stunning historical core to this myth. The discovery of a fortified trade hub in Oman that catastrophically collapsed into a sinkhole provides a plausible real-world event that could have inspired the legend. The story of a city vanishing beneath the sands may well be a dramatic retelling of a sudden geological disaster, a community's shocking end memorialized in warning tales for 1,000 years. The work of archaeologists like Dr. Stephanie Wynne-Jones is crucial in bridging this gap between folklore and fact. She and others practice a form of scientific storytelling, meticulously comparing the themes and details within oral histories with the hard data emerging from the ground. They look for alignments. Does a legend about a great flood in a particular valley correspond to sediment layers showing a massive ancient lake? Does a description of a specific type of tree or animal in a creation myth match the fossilized pollen and bones found in that region? Again and again, the answer is yes. These narratives serve as a compass, pointing researchers toward likely places to investigate, and the geological evidence, in turn, validates the cultural memory, revealing that these stories are often far older and more resilient than anyone previously imagined. This phenomenon isn't even unique to the deserts of Africa and the Middle East. On the other side of the world, in the arid American Southwest, Native American tribes like the Hopi and the Navajo have their own deep well of environmental memory. Their creation stories often begin with a previous world that was flooded or covered in water, from which their ancestors emerged into the current world. They tell of great lakes that once filled the desert basins, and of a long, arduous migration in search of water, a journey that perfectly mirrors the scientific understanding of how the region dried out at the end of the last ice age, forcing both animals and humans to move toward the few remaining rivers. These aren't just spiritual accounts, they are a people's history of adaptation and survival in the face of monumental climate shift, encoded in a form that could survive for millennia without a single written word. So why do these stories of lost watery worlds resonate so deeply across so many different cultures? Psychologists and anthropologists suggest it taps into something fundamental about the human experience. A catastrophic environmental change, like a lake drying up or a river vanishing, is a deeply traumatic event that disrupts everything a society knows: where to find food, how to travel, the very location of home. Transforming that trauma into a story, perhaps with moral lessons about humility or resilience, is a way to process the event, to make sense of the incomprehensible, and to ensure that future generations remember the warning signs. These myths become a survival mechanism in their own right, a cultural DNA that carries critical information about environmental volatility. This beautiful intersection of science and storytelling doesn't diminish the power of the myths, it amplifies it. It suggests that our ancestors were not just storytellers but keen observers and historians of their world. They witnessed profound changes and found a way to make them eternal. Their legends are more than just echoes, they are a conversation with the past, a reminder that the line between geology and folklore, between data and drama, is far thinner than it seems. They teach us that sometimes the most important truths about our planet are not found in a scientific paper, but in the stories we tell about who we are and the world we once knew. Just when we think we have the past neatly mapped out, the deserts of our world deliver a stunning surprise, overturning long-held beliefs and rewriting the very chapters of our history books. This isn't a field of study gathering dust on a shelf. It's a dynamic, ever-evolving detective story where every passing year brings a new breakthrough technology or a chance discovery that shatters our assumptions. The pace of discovery is so rapid that a theory considered solid fact just a decade ago can be completely upended by a single find tomorrow. And nowhere is this more thrilling than in the ongoing quest to uncover the secrets buried beneath the sand. Consider the most extreme desert on our planet, Antarctica. We picture it as a frozen, lifeless wasteland, a continent of solid ice. But in 2020, researchers made an announcement that seemed to defy logic. Using sophisticated ice-penetrating radar, they discovered evidence of a massive, hidden hydrological system deep beneath the ice sheets. This wasn't just a pocket of water. It was a vast collection of rivers and lakes, some the size of cities, actively flowing and shifting the ice above them. This revelation in the coldest desert on Earth proves that the dynamics of water are at work even in the most unforgiving environments, suggesting that life might persist in these dark, subglacial worlds and completely changing our understanding of how ice sheets move and behave over time. On the opposite end of the spectrum, in the hot and hyper-arid Atacama Desert of Chile, a different kind of discovery points to an equally dramatic past. This desert is so dry that scientists use it as a model for the surface of Mars, yet scattered across its barren plains are the immense, bleached skeletons of whales. Finding marine giants stranded in the driest place on Earth is a surreal and powerful image. These fossils, along with widespread deposits of marine sediments and ancient shoreline terraces, are undeniable proof that the Atacama was once submerged under the Pacific Ocean. The entire region was a deep seafloor that was violently thrust upward by tectonic forces, lifting these marine graveyards high and dry into the sky, where they now rest as a breathtaking monument to geological upheaval. Back in the realm of human history, technology is giving us a god's eye view of lost landscapes. In the Arabian desert, archaeologists are now using LiDAR, light detection and ranging technology. By flying over the sand seas with laser scanners, they can effectively strip away the layers of modern sand to create a detailed, three-dimensional map of the hidden terrain below. This has revealed an astonishing network of ancient river channels and lost oasis settlements that were completely invisible from the ground. These weren't just small campsites, they were complex, interconnected communities that thrived along these vanished waterways, rewriting the narrative of how early humans not only crossed but truly inhabited and transformed the Arabian Peninsula during its green phases. Perhaps one of the most intimate and haunting recent finds comes from White Sands National Park in New Mexico. There, erosion revealed a set of pristine ancient footprints preserved in the white gypsum of a dried-up Pleistocene lake bed. But these weren't just any footprints. Researchers, including Dr. Matthew Stewart, documented a breathtaking snapshot of prehistoric life, the tracks of a giant ground sloth walking in a straight line, immediately followed by the footprints of a human hunter stalking it. A short distance away, the tracks show the sloth rising up on its hind legs to defend itself, a moment of drama frozen in time for over 10,000 years. This single discovery provides irrefutable, tangible evidence of human interaction with Ice Age megafauna, offering a visceral connection to a day in the life of our ancient ancestors and their struggle for survival. Each of these discoveries does more than just add a new pin to our historical map. They fundamentally reshape our theories. The Antarctic rivers force climatologists to rethink ice sheet stability. The Atacama whales provide a brutal case study in rapid tectonic change. The lidar-mapped oases in Arabia are redrawing the routes of human migration out of Africa. The White Sands footprints provide undeniable proof of human presence in North America, much earlier than previously believed, and show direct interaction with now extinct creatures. This relentless wave of new evidence ensures that the story of our planet is never finished. It begs the question of what other profound secrets remain hidden, waiting for the right technology, the right storm, or the right curious mind to uncover them, ensuring that the deserts will continue to be the greatest source of historical mysteries for generations to come. To truly understand the story of water in the desert, we need to become detectives of deep time, learning to read the subtle clues left behind. This is the fascinating realm of paleohydrology, the scientific discipline dedicated to reconstructing Earth's ancient water cycles. And there is no better place to practice this detective work than in the world's deserts. Their arid nature is their greatest gift to science, with minimal vegetation to obscure the ground and little rainfall to cause erosion. The evidence of past rivers, lakes, and floods remains astonishingly well preserved, laid out like an open book waiting to be read. The tools of the paleohydrologist are as diverse as they are ingenious. It begins with a careful reading of the land itself. In the Taklamakan Desert of western China, along the ancient Silk Road, the stark, wind-swept landscape holds a secret. Geologists studying the edges of the desert have found massive, bench-like formations known as river terraces. These are the fossilized remnants of ancient riverbanks, cut by flowing water that was far mightier than anything in the region today. By mapping and dating these terraces, scientists can trace the former courses of rivers that once sustained thriving ecosystems and provided vital oases for the caravans that connected east and west. This isn't just geology, it's a key to understanding how human civilization flourished in some of the most challenging environments on Earth. But the most detailed chapters of this watery history are often found in the most unexpected places, deep within desert caves. In caves across the arid American Southwest, Oman, and elsewhere, stalagmites rise from the floor like stone trees, and each one contains a breathtakingly precise record of past rainfall. As water drips from the cave ceiling, it leaves behind a tiny deposit of minerals, building the stalagmite up layer by layer over thousands of years. Trapped within each of those microscopic layers are oxygen isotopes, slightly different forms of the oxygen atom. The ratio of these isotopes changes depending on the temperature and the amount of rainfall at the time the layer was formed. By drilling a tiny core from a stalagmite and analyzing these isotopes, researchers like Professor Kathleen Johnson can create a year-by-year timeline of precipitation stretching back tens of thousands of years. It's like having a highly accurate rain gauge that was set up in the cave during the last ice age, faithfully recording data ever since. These climate records derived from caves and other desert archives are not just about satisfying historical curiosity. They are absolutely critical for testing and improving the computer models that scientists use to predict our future climate. By feeding data about past conditions, how much carbon dioxide was in the atmosphere during a previous warm period, or how quickly rainfall patterns shifted when the Sahara dried out into these powerful models, climatologists can see if the models accurately simulate the changes we know actually happened. If a model can successfully retrodict the past, we can have far more confidence in its predictions for the future. This allows us to create more reliable forecasts for water availability, drought risk, and agricultural sustainability in arid regions that are home to billions of people. Perhaps no single case study illustrates the power of paleohydrology more dramatically than the story of Lake Chad. Satellite images of the Sahara today show a relatively small Lake Chad, a water body that has been shrinking alarmingly in recent decades. But the geological evidence reveals a past of almost unimaginable scale. Just 5,000 years ago, this same spot was covered by a vast inland sea known as Lake Chad. At its peak, it was the largest freshwater lake on Earth, larger than the Caspian Sea is today, covering over 350,000 square kilometers of what is now Chad, Nigeria, Niger, and Cameroon. Its remnants are everywhere, vast, flat plains of diatomite, a rock made from the skeletons of ancient lake algae, and ancient shorelines carved into the mountains of northern Chad, hundreds of feet above the current desert floor, testify to its former glory. Reconstructing the life and death of this mega lake provides a sobering lesson in climate volatility. Paleohydrologists have pieced together its history using a combination of sediment cores and satellite radar topography. They've learned that the lake expanded and contracted dramatically with the changing climate, profoundly influencing the human societies that lived on its shores. Its final demise as a mega lake was a result of the same climatic shifts that dried out the Sahara, forcing populations to disperse and adapt to a much harsher reality. This deep historical context is vital for understanding the challenges facing the region today. The current crisis of a shrinking Lake Chad is not an isolated event. It is the latest chapter in a long story of environmental change. By understanding the natural rhythms of the past, we can better distinguish between human-caused change and natural cycles, and develop more effective, long-term strategies for managing this precious resource. This scientific discipline does more than just reveal lost worlds. It provides the essential context we need to navigate the challenges of our own. Among the most magical and fleeting sights in any desert is the sudden appearance of water where none should be. These ephemeral lakes, known as playas or pans, are the desert's way of briefly remembering its wetter past. They form in shallow, flat-bottomed depressions after a rare, heavy rainfall, transforming a sun-baked clay basin into a vast, shimmering inland sea almost overnight. This isn't a slow, gradual change. It's a sudden and breathtaking metamorphosis that completely rewrites the rules of the landscape, if only for a little while. The most spectacular example of this is Australia's Catty-Tanda Lake Eyre. For years, this massive 9,000 square kilometer basin can lie completely barren, a cracked and salt-encrusted plain under the relentless outback sun. But when the rains finally come, often from monsoon systems hundreds of miles away in Queensland, the desert undergoes a miracle. Water begins to flow through a network of dry river channels, finally pooling in the Great Basin, and within weeks, a vast, shallow lake appears, sometimes reaching depths of several meters. This sudden abundance of water acts like a giant dinner bell for the entire continent. Flocks of banded stilts and pelicans, sensing the change from incredible distances, arrive by the hundreds of thousands to breed on the newly formed islands. Fish eggs that have lain dormant in the dry mud for years suddenly hatch, and the entire ecosystem explodes into a frantic, joyous burst of life, all racing against the clock before the water inevitably vanishes again. But not all desert lakes rely solely on the sky. In the stunning Badain-Jaran Desert of China, a remarkable paradox exists among some of the world's tallest stationary dunes. Nestled in the valleys between these massive mountains of sand are over 100 permanent lakes. Their existence defies logic until you understand their secret source. They are not filled by rain, but by a vast, ancient aquifer that lies deep beneath the desert. Snowmelt and rainfall from the distant Kilian Mountains, hundreds of kilometers away, percolates through the ground, traveling through porous rock for centuries before being forced back to the surface by impermeable layers below. These springs well up between the dunes, creating stunning oases of brilliant blue and green water that are stabilized by this constant, slow recharge from the depths. This creates a completely different kind of ephemeral system, not one defined by the lake itself vanishing, but by the delicate balance between the spring inflow and the incredible evaporation rate under the desert sun. Scientists meticulously study the chemistry and water levels of these lakes because they are like vital signs, monitors for the health of the entire regional groundwater system. A drop in their level is a silent alarm that the ancient water bank account is being overdrawn. The scientific value of these coming and going lakes is immense. They are natural laboratories for understanding the very processes that shaped the prehistoric mega-lakes we've been exploring. By studying how quickly Lake Eyre evaporates, researchers can create more accurate models for how quickly the giant Lake Mega-Chad might have shrunk thousands of years ago. By taking core samples from the sediments deposited on the floor of a playa each time it fills, geologists can read a detailed history of past rainfall events, much like reading the rings of a tree. Each layer of silt and organic material represents a single filling episode, allowing them to reconstruct a chronology of droughts and floods stretching back millennia. Furthermore, observing how flora and fauna respond to these brief windows of opportunity provides profound insights into resilience and adaptation. The creatures that call these places home don't fight the cycle. They have evolved to embrace it with breathtaking precision, their entire life cycles synced to the unpredictable rhythm of the water. Modern technology allows us to witness this ephemeral dance in ways never before possible. Time-lapse satellites like those in NASA's Landsat program capture the entire life cycle of a desert lake from birth to death, showing the water's advance and retreat across the basin in a series of starkly beautiful images. On the ground, filmmakers and scientists set up cameras to document the incredible transformation, compressing months of activity into seconds of video that show the cracked earth dissolving under a sheet of water, followed by an explosion of green and the frantic arrival of wildlife. This visual evidence is powerful because it makes the abstract concept of climatic cycles tangible and immediate. We can see the desert breathe. This captivating spectacle touches something deep within us. Perhaps it's the powerful metaphor of hope and renewal, the undeniable proof that life, however harsh the conditions, will seize any opportunity to flourish. These fleeting oases teach us that resilience isn't about withstanding constant pressure, but about developing the incredible ability to spring to life when the moment is right, to make the most of abundance in the face of certain scarcity. They are a beautiful, real-time echo of the grander cycles that have shaped the history of every desert on Earth, a reminder that the line between a wasteland and a paradise is often just a few inches of rain. This incredible reshaping of the desert world wasn't just a change of scenery. It was a powerful evolutionary force that dictated the very survival of countless species. As the Great Lakes of the Sahara shrank into salt flats and the rivers of Arabia vanished beneath the dunes, the animal kingdom faced an ultimatum that would determine its fate for millennia to come: adapt, move, or perish. The fossil record tells this dramatic story with heartbreaking clarity. In places that are now nothing but sand, paleontologists have unearthed the bones of hippos that once wallowed in vast wetlands, the skulls of lions that prowled through grasslands, and the massive tusks of elephants that roamed a landscape we can now only imagine. These weren't isolated creatures, they were part of a thriving ecosystem that mirrored the savannas of modern-day East Africa. The evidence is so concrete that you can stand in the Tenere Desert of Niger, a place of almost unimaginable dryness, and hold the fossilized tooth of a giraffe in your hand, a tangible relic of a world turned upside down by climate. To track the epic journeys and tragic endings of these species, scientists have become masters of forensic ecology. A single bone fragment is a treasure trove of information. By analyzing the isotopes locked within fossilized teeth and tusks, researchers can determine what an animal ate and even the type of environment it lived in, distinguishing between a diet of dry grasses and lush wetland vegetation. This chemical signature acts as a permanent passport, stamping where a creature lived and what it experienced throughout its life. Even more powerful is the analysis of ancient DNA, extracted from well-preserved specimens. This genetic material allows experts to trace lineage and migration patterns. For instance, DNA from North African elephant fossils shows a close relation to both modern African forest elephants and the extinct straight-tusked elephants of Eurasia, painting a picture of a once continuous population that was eventually fragmented and pushed southward as the desert expanded, creating the separate species we know today. The story isn't always a simple one of climate versus nature. Prominent archaeologists like Dr. Elena A. Garcia have pieced together a more complex narrative, one where the changing environment intersected with the growing prowess of another species, humans. Her work across the Sahara suggests that the decline of the region's iconic megafauna wasn't solely due to the desert's advance. As the climate became more stressful and water sources became scarce and isolated, large animals like buffalo and hippos were forced to congregate around the few remaining oases. This made them tragically easy targets for human hunters who had also become concentrated in these same areas. It was a devastating one-two punch. A changing climate squeezed species into smaller pockets of habitat, and then human predation pushed already vulnerable populations over the edge into extinction. This offers a sobering lesson from the deep past about how environmental stress can amplify the impact of human activity. Yet, amidst these stories of loss, there are also incredible tales of evolutionary triumph, and no animal embodies this better than the camel. The very creature we see as the ultimate symbol of the desert began its journey in a completely different world. The earliest camel ancestors, like the rabbit-sized Protolopus, actually evolved in North America over 40 million years ago and later spread into Asia. Some species eventually made their way to Africa during its green phases, thriving in the wetlands and forests. But when the good times ended and the water vanished, these animals faced a critical evolutionary crossroads. Over millions of years, natural selection favored the individuals best equipped to handle the new, harsh reality. Their bodies transformed in remarkable ways, They developed fat-storing humps to serve as energy reserves on long, food-scarce journeys. Their kidneys evolved to produce highly concentrated urine to conserve every drop of water, and they grew those iconic long eyelashes and closable nostrils to protect themselves from relentless sandstorms. The camel we know today is not a creature that was always built for the desert. It is a masterpiece of adaptation, a former resident of a wetter world that reinvented itself completely to survive and ultimately dominate its new, arid home. These ancient narratives of migration, extinction, and adaptation are far more than just historical curiosities. They are a vital framework for understanding the ecological crises we face today. As modern climate change and human activity accelerate desertification across the globe, we are effectively running a real-time experiment on a planetary scale. The saga antelope of Central Asia's steppes, which already survives on minimal water, now faces new pressures from a warming climate and habitat loss. The unique creatures of the Mojave Desert, like the desert tortoise, are seeing their fragile ecosystems disrupted by prolonged droughts and increasing temperatures. The lessons from the past are clear. Species can be remarkably resilient, but they need time and space to adapt. When change happens too quickly, and when their migration routes are blocked by human development like cities and farms, the result is not adaptation but collapse. The fossil record shows us the consequences of getting this balance wrong, but it also shows us the incredible power of life to find a way. Our challenge is to apply that deep time wisdom, to create corridors for wildlife to move and to mitigate the pressures we control, ensuring that the current wave of desertification doesn't become another chapter of irreversible loss in the great book of life. Looking ahead to the future of our planet's arid regions, the lessons etched into the very sands of history become more vital than ever. With modern climate change accelerating desertification in some areas while potentially greening others, the deep time stories of shifting sands and vanished rivers offer us something priceless, a blueprint for resilience. This isn't just about understanding the past, it's about using it to navigate an uncertain future. One of the most ambitious projects drawing inspiration from this concept is Africa's Great Green Wall initiative. This monumental effort aims to grow an 8,000-kilometer-long mosaic of trees, vegetation, and fertile land across the entire width of the continent, right at the southern edge of the Sahara Desert. The vision is not merely to plant trees but to restore entire ecosystems, combat poverty, and create a natural barrier against the encroaching desert. The very idea is rooted in a powerful historical truth that this land was once green on its own. By understanding the natural cycles that allowed forests and savannas to thrive there, scientists and farmers are selecting native, drought-resistant species that have the best chance of surviving and, in turn, triggering a positive feedback loop where increased vegetation attracts more rainfall, slowly reclaiming the land from the desert. This forward-thinking vision is beautifully complemented by a return to ancient wisdom. For centuries, desert-dwelling civilizations developed incredibly sophisticated methods to harness every drop of water, and modern engineers are now looking to these time-tested techniques for inspiration. In the arid highlands of Iran and Afghanistan for over 2,000 years, communities have built and maintained qanats, gently sloping underground tunnels that tap into groundwater trapped in foothills and channel it for miles using only gravity, delivering a steady, reliable flow to villages and fields while minimizing evaporation loss. Similarly, in Israel's Negev Desert, archaeologists have studied ancient Nabatean and Byzantine systems of low stone walls called check dams built across dry riverbeds. These simple structures were designed to slow the destructive rush of flash floods, allowing water to percolate into the soil and recharge the groundwater, rather than washing away the precious topsoil. Today, these principles are being revived in modern form. Permaculture designers and water managers are building swales, shallow, water-harvesting ditches on contour lines across landscapes and constructing small check dams to capture rainwater where it falls, replicating the ancient strategy of encouraging infiltration over runoff. The key to applying these lessons effectively lies in the powerful merger of old and new. Paleoclimatologists provide the crucial long-view data, using everything from fossil pollen records to stalagmite isotopes to predict how regional rainfall patterns might shift under various warming scenarios. This helps policymakers and urban planners make informed decisions. Should a city invest in expensive desalination plants, or would a distributed network of ancient-style rainwater harvesting systems be more resilient? Is a particular region likely to become drier, making large-scale agriculture unsustainable, or might it actually see increased monsoon rains, allowing for carefully managed restoration? Experts like Dr. Diana Liverman, a leading geographer who focuses on human dimensions of global environmental change, powerfully advocate for this integrated approach. She emphasizes that technological silver bullets alone cannot solve water scarcity. We must combine cutting-edge science with the decentralized, community-based, and low-energy solutions that ancient cultures perfected through centuries of trial and error. This means empowering local communities to manage their own water resources using a blend of traditional knowledge and modern meteorological data. Ultimately, this isn't just a technical challenge, it's an ethical one. The fossil water aquifers we are rapidly depleting were filled during those ancient green periods, and they represent a non-renewable inheritance. Using them for water-intensive crops in the middle of a desert is, in a very real sense, living off capital that can never be replaced. The wisdom of the past teaches us the principle of working within natural limits, not constantly trying to overcome them with brute force. By learning from the Garamantes who tapped fossil water wisely, from the Nabateans who celebrated every drop of rain, and from the countless cultures that adapted rather than fought the climate, we can forge a path toward true sustainability. This forward-looking approach transforms historical mysteries from fascinating stories into a practical toolkit for survival, urging us to build a future that is not only technologically advanced but also deeply wise, resilient, and in harmony with the profound lessons of the Earth itself. Uncovering the secrets buried beneath the desert sand is a task that demands more than just shovels and brushes. It requires a delicate, almost surgical approach to avoid destroying the very history you're trying to save. The arid environment is a fantastic preservative, but the clues it protects: fragile bone, ancient seeds, mud brick walls that crumble at a touch, are incredibly vulnerable the moment they're exposed. This is why modern desert archaeology has evolved into a high-tech discipline, where the first rule is to look without touching, to map without disturbing, using an array of tools that feel more like they belong in a science fiction novel than on a dig site. Before a single grain of sand is ever moved, archaeologists now scan the entire area from above and below. Drones equipped with high-resolution cameras and thermal sensors fly systematic grid patterns over vast stretches of desert, capturing minute variations in the surface that are invisible to the human eye. A slight depression in the ground might indicate a buried pit house. A subtle difference in vegetation growth could reveal the outline of an ancient wall just beneath the surface. But the real magic happens beneath the ground. Ground-penetrating radar, or GPR, is one of the most revolutionary tools in the kit. This device is slowly dragged across the desert floor, sending high-frequency radio pulses into the earth. These pulses bounce back whenever they hit something with a different density: a buried stone foundation, a ceramic pot, or even the compacted floor of an ancient hearth. The returning signals are compiled by a computer to create a detailed three-dimensional map of the subsurface, a ghostly image of the buried world that allows archaeologists to pinpoint exactly where to dig, saving countless hours and ensuring they don't miss a single important feature. This technology was put to spectacular use in the Egyptian desert, where a team investigating a now barren region used GPR to identify a series of mysterious circular anomalies buried deep beneath the sand. Guided by these subterranean maps, their subsequent excavation revealed a Neolithic settlement dating back over 7,000 years, complete with grinding stones, pottery, and the remains of hearths. These weren't just random artifacts, they were the debris of daily life from a time when this part of the Sahara was a grassy savanna. The precise location of each object, meticulously recorded with GPS coordinates, told a story of how the settlement was organized, giving us an unprecedented window into the lives of some of the earliest people who called the Green Sahara home. The work of archaeologists like Dr. Rebecca Foote in Saudi Arabia showcases how these methods are piecing together an entirely new history of the Arabian Peninsula. Her excavations focused on the sites of ancient, long-vanished lakes, using satellite imagery to identify the ghostly shorelines of these paleolakes. Her team then employed GPR and magnetometry, which measures tiny variations in the Earth's magnetic field caused by buried fired clay or hearths, to locate settlements that once thrived on the water's edge. The excavations that followed were exercises in meticulous precision. They didn't just dig down, they peeled back history layer by paper-thin layer, documenting the exact position of every artifact and every change in soil color or texture. In one such lakebed settlement, they uncovered not just stone tools, but the very floors of dwellings and the ashes of cooking fires, allowing them to reconstruct the layout of an entire community that had gathered around a life-giving lake 10,000 years ago. Some of the most telling evidence from these sites isn't found with the naked eye at all. It's recovered through a process called flotation. Archaeologists take buckets of soil from specific features, like a storage pit or an ancient trash midden, and submerge them in water. The lighter materials, the tiny, precious carbonized seeds of ancient plants, bits of charcoal, and micro-fragments of bone, float to the surface where they are skimmed off with a fine mesh sieve. This delicate material is a treasure trove of information. Analyzing the seeds under a microscope can reveal what crops people were growing or what wild plants they were gathering. A piece of charcoal, no bigger than a fingernail, can be radiocarbon dated to give the site an absolute age. This process transforms a handful of dirt into a detailed menu of the past diet and a precise timestamp for human occupation. Even the dirt itself tells a story through a technique known as soil micromorphology. Researchers take small, undisturbed blocks of soil, impregnate them with resin to make them solid, and then slice them into sections thin enough to be examined under a petrographic microscope. At this magnified level, the soil reveals its history like a layered cake. You can see individual grains of sand deposited by wind, thin layers of clay laid down by slow-moving water, and the microscopic crystals of salts that formed as a lake finally evaporated. Most fascinatingly, you can sometimes spot the faint imprint of a plant root or the microscopic evidence of animal dung, proof positive of the life that once flourished there. This isn't just studying dirt, it's reading the autobiography of the landscape, written in a language of minerals and microfossils. All of this painstaking work, the remote sensing, the careful excavation, the flotation and micromorphology, converges to achieve a single, almost magical goal. It allows us to step into a lost world. We move beyond simply knowing that a lake was there. we can understand how deep it was, how seasonal its waters were, and what kinds of fish swam in it. We don't just find a settlement, we can see the layout of its homes, understand what its inhabitants ate for dinner, and feel the texture of their daily lives. The precision of modern archaeological science grants us the profound ability to reach across millennia and touch the past directly, not as a vague legend, but as a tangible, reconstructed reality, forever enriching our understanding of how humanity has continually adapted to the Earth's great transformations. While the relentless sun and crushing dryness of a desert might seem like agents of destruction, they are often outshone by a far more active and creative force, the wind. This invisible sculptor is the master architect of the arid world, endlessly picking up, carrying, and depositing billions of grains of sand, constantly reshaping the landscape. But this same force that erases features from the map also performs a vital, paradoxical service. It acts as a master curator, carefully burying and preserving the past beneath a protective blanket of sand. The very process that creates the desert's stark beauty is also what saves its history from being lost forever. This constant movement of sediment by wind is known as Aeolian processes, named after Aeolus, the Greek god of the winds. It begins with the smallest, finest particles of dust and sand. When a gust sweeps across a dry lakebed or a rocky plain, it doesn't have the power to lift large rocks, but it can easily entrain these tiny grains, bouncing them along the surface in a process called saltation. As these hopping grains strike others, they knock them loose, creating a cascading effect that can set entire fields of sand in motion. Over immense spans of time, this relentless, grain-by-grain migration builds the iconic features we associate with deserts. Vast sand seas, known as ergs, can stretch for hundreds of miles, their waves of dunes frozen in time. Larger, more complex dune structures called draw form the massive backbone of these sandy oceans, their immense scale only truly appreciable from the air. The preserving power of this drifting sand is nothing short of miraculous. Imagine an ancient campsite on the shore of a dying lake. As the climate dries, the wind begins to pick up loose sediment from the exposed lakebed and deposit it over the abandoned tools, hearths, and bones left behind. Layer by minuscule layer, the site is sealed off from the elements. This sandy tomb creates an environment that is dark, dry, and stable, conditions that are perfect for preservation. Without oxygen or moisture, organic materials that would normally rot in a matter of years can survive for millennia. This is spectacularly evidenced in the Taklamakan Desert of western China, where the extreme dryness and constant sand burial have preserved human remains, textiles, and even ancient documents in such perfect condition that they look like they were interred only a few decades ago, not over 2,000 years ago. For geologists and archaeologists, understanding the language of dune migration is like learning to read the desert's hidden calendar. By studying the shape, orientation, and movement of sand dunes, they can make educated predictions about what might lie buried in their path or what could be revealed in their wake. They employ a clever technique called luminescence dating to determine not the age of the sand itself, but the last time it was exposed to sunlight. The minerals that make up sand, like quartz and feldspar, store energy from natural background radiation over time. When a grain of sand is buried, it is shielded from sunlight, which acts as a reset button, and it begins storing this energy again. By measuring how much energy has been stored in a sample of sand taken from a specific layer, scientists can calculate precisely when that grain was last buried, providing a reliable timestamp for the archaeological material it encases. This interplay between wind-driven burial and revelation leads to some of the most thrilling and accidental discoveries. A powerful storm or a period of unusual wind patterns can scour away tons of sand in a matter of days, acting like a natural excavation team. This was the case in Arizona's Vermilion Cliffs National Monument, where a hiker stumbled upon an incredible sight after a windstorm had cleared a large patch of sandstone, a pristine set of dinosaur footprints. These tracks, made by a three-toed theropod dinosaur over 200 million years ago, had been hidden under a protective layer of sand and sediment for eons, only to be briefly unveiled by the very same force that had concealed them. It was a fleeting glimpse into a deep time world offered by a shift in the wind. This creates a fascinating dynamic of hide and seek between the desert and those who seek to understand it. The wind giveth and the wind taketh away. It can spend centuries carefully burying a lost city, preserving it perfectly, only to change its mind centuries later and begin systematically stripping that protective layer away, exposing the ruins to the elements and potential looting. This delicate dance means that exploration and conservation are often a race against time. The same process that protects history also makes it incredibly difficult to find, and the moment it is found, its preservation is immediately threatened. This paradox lies at the heart of desert archaeology, a constant reminder that the secrets of the sand are bestowed temporarily, urging us to learn, document, and protect them while we can. But how can we possibly know what the Sahara looked like 10,000 years ago, or predict what it might look like 10,000 years from now? The answer lies in one of the most powerful tools of modern science, the climate model. These are not simple weather forecasts. They are incredibly complex digital replicas of our entire planet, built inside supercomputers. Scientists can feed these models with data from the deep past, like the chemical fingerprints locked in ice cores or the growth rings of ancient trees, and then set the virtual Earth spinning to see if their understanding of climate physics can accurately recreate the world as we know it was. It's the ultimate test of our knowledge, a way to run experiments on the planet's history that would be impossible any other way. To bring a past world like the Green Sahara to life inside a computer, researchers begin by gathering every clue they can find. They take samples from deep ice cores in Greenland and Antarctica, which contain tiny bubbles of ancient air, preserving the exact atmospheric composition of the past. They analyze sediment cores from the ocean floor and from the beds of long-vanished lakes, which hold layers of pollen and dust that tell us what was growing on the land and how dry it was. They study the rings of ancient bristlecone pines and submerged fossilized cypress stumps, which record years of good rain and years of terrible drought. This mountain of paleoclimate data provides the target. The modelers then program all the fundamental rules of physics: how sunlight heats the ground, how evaporation cools the ocean, how winds move moisture across continents, into a sophisticated software framework like the Community Earth System model. They dial the virtual Earth's orbital parameters back to where they were 11,000 years ago, a configuration that brings the monsoon rains farther north, and then they press play. What happens next is nothing short of magic. The digital planet awakens. On the screen, the simulated Sahara, which started as a barren desert, begins to transform. Pixel by pixel, green emerges. Rainfall increases over North Africa. Virtual rivers begin to flow across the landscape, and the model calculates how this new moisture would encourage the growth of grasses and shrubs. This is where the real magic of feedback loops comes in. The initial orbital change brings more rain, which allows plants to grow. Those plants then change the color of the land, making it darker. A darker surface absorbs more heat from the sun, which warms the air above it, causing it to rise and pull in even more moist air from the oceans, which leads to even more rain. This positive feedback loop, a dance between vegetation and climate, is what the models show could have turbocharged the greening of the Sahara, transforming it from a desert to a savanna in a surprisingly short amount of time. The pioneering work of climatologists like Dr. Martin Clausen has been absolutely central to understanding this process. His simulations were among the first to demonstrate just how sensitive the Sahara is to tiny nudges from Earth's orbit and changes in greenhouse gases. He showed that the transition between a green and a desert state isn't always a slow, gradual fade. It can be a relatively abrupt tipping point. Once the climate forcing passes a certain threshold, the entire system can flip from one stable state to another, with the vegetation-climate feedback loop acting as the amplifier that pushes it over the edge. This doesn't just explain the past, it gives us a crucial framework for thinking about the future. If the Sahara can flip from wet to dry because of a small change, could it flip back? This is the critical question that moves climate modeling from a theoretical exercise into the realm of actionable knowledge. Our current global experiment of pumping vast amounts of carbon dioxide into the atmosphere is a forcing far more powerful and rapid than the slow wobbles of Earth's orbit. When scientists input these modern greenhouse gas concentrations into the same models that successfully recreated the African humid period, they get some startling and complex results. Some projections suggest that a warmer atmosphere which can hold more moisture might actually lead to increased rainfall and a greening of the Sahel region just south of the Sahara. We may already be seeing early signs of this in satellite data. However, this potential benefit is a double-edged sword. This greening is unlikely to be uniform or stable. It could be offset by more intense and frequent droughts in the same region, and the increased heat could lead to greater evaporation, potentially negating the extra rainfall. In other deserts like the American Southwest, the models paint a much grimmer picture, forecasting a long-term, permanent drying known as aridification. These digital recreations are therefore the ultimate bridge, connecting the mysteries of our past to the uncertainties of our future. They take the scattered, fossilized clues buried in the desert and weave them into a coherent, testable narrative of how Earth works. By proving they can accurately retrodict the past, the models earn our confidence in their predictions for what is to come. This high-tech approach transforms the Sahara's story from a fascinating historical anecdote into a vital case study, providing us with a profound understanding of the delicate balances and powerful feedbacks that govern our planet's arid lands, and offering a preview of the profound changes we might expect as we continue to alter the very atmosphere that makes it all possible. Today's most forbidding deserts once served as the world's greatest superhighways, guiding the footsteps of our earliest ancestors during brief windows of opportunity opened by a shifting climate. We often imagine these arid expanses as impenetrable barriers, but for Homo sapiens, they were dynamic corridors, gateways to new continents and new futures. This incredible story of human movement is written not in stone, but in water, or more precisely, in the memory of water that once flowed where now there is only sand. The same green phases that transformed the Sahara into a savanna and filled Arabia's empty quarter with lakes also created a navigable landscape for migration, turning dead ends into throughways and isolation into connection. We can trace these epic journeys through a powerful combination of cutting-edge science. Geneticists analyzing the DNA of modern populations can detect subtle markers that act like breadcrumbs, revealing the paths our ancestors took out of Africa and across the globe. These genetic signatures show that today's diverse human populations outside of Africa all stem from a few small groups who successfully made these arduous crossings. Meanwhile, archaeologists on the ground find the physical evidence they left behind. carefully crafted stone tools, the bones of the animals they hunted, and the ashes of their campfires, all strategically located along the ghost banks of ancient rivers and lakes. By overlaying these findings with paleo-environmental data, maps of where water once was a clear picture emerges. People didn't wander blindly into the desert. They followed the water, moving along fertile river valleys and setting up seasonal camps on the shores of vast lakes that have long since vanished. The work of researchers like Dr. Michael Petraglia has been instrumental in mapping this lost world. His teams have combed the Arabian Peninsula, focusing on areas that satellite data and geological surveys indicate were once green. In one striking example, excavations in the Nephod Desert of Saudi Arabia uncovered a site called Al-Wasta, which was once a freshwater lake. There, nestled in the ancient lakebed sediments, they found a single, elegant human finger bone. The significance of this tiny fossil is immense. Dated to around 90,000 years ago, it is among the oldest remains of Homo sapiens ever found outside of Africa and the Levant. But it wasn't alone. The same layers contained stone tools and fossils of animals that simply could not survive in a desert: hippos, wild cattle, and freshwater snails. This one site perfectly encapsulates the entire story. Humans were present, and they were there because the environment could support them. They weren't just passing through in a desperate sprint. They were thriving in a landscape that was every bit as hospitable as the African savannas they left behind. These green corridors didn't just facilitate movement, they fueled cultural and genetic exchange. As groups of hunter-gatherers moved along these well-watered routes, they would have encountered each other. Lakeshores became natural meeting points, places to share technology, stories, and genes. The exchange of new tool-making techniques or symbolic ideas likely accelerated during these periods of connectivity, driving innovation and strengthening the social networks that would be crucial for survival when the climate eventually turned harsh again. The deserts, in their green phases, acted as a crucible for human culture, forcing different groups into interaction and fostering the diversity that would eventually characterize the human species across the planet. The end of these humid periods brought this era of easy movement to a close. As the monsoons failed and the lakes dried up, the green corridors withered back into impassable desert. The pathways closed, isolating populations that had settled on the other side. This forced isolation had its own profound consequences, allowing regional cultures and genetic lineages to develop independently for thousands of years until the next shift in the climate or a new technology, like the domestication of the camel, opened the deserts again for travel. This cyclical pattern of connection and isolation, driven entirely by the presence or absence of water, is a powerful reminder that the environment is not just a backdrop for human history. It is an active director, shaping the plot of our species' story at every turn. Following these ancient water trails does more than satisfy our curiosity about the past. It reveals the profound and inseparable link between a drop of rain and the destiny of humanity. Beneath the sun-blasted surface of many deserts lies a hidden world of breathtaking complexity, a labyrinth of tunnels, caverns, and secret rivers that defies the arid reality above. These are karst landscapes, geological wonders formed not by the wind, but by the slow, patient work of water over millions of years. Imagine a vast slab of limestone, a rock that began its life as the compressed skeletons of ancient marine creatures at the bottom of a primordial sea. When this rock is exposed to even slightly acidic water, a common condition created when rainwater absorbs carbon dioxide from the atmosphere and soil, a remarkable transformation begins. The water doesn't just flow over the rock, it literally eats it away, dissolving the limestone molecule by molecule, carving out intricate passageways, colossal chambers, and deep, water-filled conduits. This process, known as chemical dissolution, creates a Swiss cheese-like structure deep underground, a hidden plumbing system that can store and transport vast quantities of water from a time when the climate was radically different. The Nullarbor Plain in southern Australia offers one of the most spectacular examples of this phenomenon. Its name, derived from the Latin for no tree, perfectly describes its flat, featureless surface that stretches for over 1,000 kilometers. But look beneath this barren facade, and you enter a different universe. The Nullarbor sits atop one of the world's largest single exposures of limestone, and it is riddled with hundreds of caves and sinkholes. These are not just empty holes, they are time capsules. As water dripped through the rock over millennia, it deposited layers of calcite, forming stunning stalactites, stalagmites, and flowstones. But these formations are more than just beautiful, they are a climate archive. Speleologists, the scientists who study caves, can drill into a stalagmite and analyze its chemical composition layer by layer. The ratio of different oxygen isotopes within each tiny layer acts as a precise paleothermometer and rain gauge, recording the temperature and amount of rainfall at the time that layer was formed. A thick, rapidly deposited layer indicates a wet, warm period, while a thin, slowly grown layer speaks of drought and aridity. In this way, a single cave formation can provide a continuous, high-resolution record of climate change stretching back hundreds of thousands of years, a narrative of environmental shifts written in stone. This same scientific approach has yielded incredible insights in the caves of the Judean Desert near the Dead Sea. Here, in one of the hottest and driest places on Earth, researchers have analyzed stalagmites from caves like Sorek Cave to reconstruct a detailed rainfall history of the Levant spanning more than 200,000 years. Their findings have provided crucial context for human history, revealing periods of severe drought that would have challenged ancient societies, as well as wetter intervals that may have facilitated the development of agriculture and the growth of early cities. The very presence of these extensive karst systems in such an arid environment is itself a clue. It is a relic of a much wetter past when plentiful rainfall was available to carve out these massive underground networks. The water that still flows through them today is often fossil water, a lingering echo of those ancient downpours. Beyond their value as climate archives, these subterranean worlds are sanctuaries for life. Cut off from the harsh surface environment, desert caves develop their own unique ecosystems. Specialized, often eyeless creatures have evolved to thrive in the perpetual darkness and constant humidity. In the caves of the Mojave Desert, rare troglobitic insects and crustaceans are found nowhere else on the planet, living relics isolated for millennia. For humans, these features have always been vital. Sinkholes where the roof of a cave has collapsed to reveal the water below have served as natural oases for countless generations. Indigenous cultures across the world's deserts have long known of and relied upon these hidden water sources. The caves themselves provided shelter from the blistering sun and freezing nights, their walls often adorned with rock art that pays homage to the life-giving power of the secret waters within. Delving into these underground realms does more than just uncover another layer of Earth's hydrological memory. It reveals a parallel desert world, one of resilience, hidden abundance, and a deep, enduring connection between the planet's past and the life it sustains. These stunning galleries of rock art are far more than ancient decoration. They are the most direct and emotionally powerful evidence we have of the world that once was. Imagine an artist thousands of years ago, sitting in what is now the heart of the Sahara, carefully mixing pigments from ochre and charcoal to paint a scene of daily life on a sheltered sandstone wall. But the scene they choose to immortalize isn't one of sand and scarcity. It shows people gracefully diving into deep water, herds of cattle with elegant, sweeping horns, and animals like giraffes and hippos that could never survive in the desert we see today. This is the magic of places like the Cave of Swimmers in the Gilf Kebir Plateau of Egypt. The name itself is a declaration of a lost reality. The figures depicted are caught in mid-motion, their bodies arcing through what was clearly a plentiful body of water, a scene so utterly at odds with the surrounding sea of dunes that it feels like a message from another dimension. For a long time, these paintings were seen as symbolic or mythological, perhaps representing a spiritual belief in an underworld of plenty. But we now understand they are something far more profound. They are snapshots, literal depictions of the environment as the artists experienced it. To an expert eye like that of Dr. Jean-Loic Lequelec, these artworks are a detailed historical archive waiting to be decoded. Archaeologists don't just look at what is painted, they analyze how it was painted. The artistic style, the types of tools used to create the images, and the precise mix of pigments all act as cultural fingerprints that can help place the art in a specific time period. More importantly, the subject matter provides a direct window into the climate. A painting full of lush vegetation and water-dependent animals like elephants or buffalo must have been created during a humid period. A shift in artistic themes toward images of domesticated cattle and herding signals the beginning of a drier phase as societies adapted from hunting to pastoralism. Later still, the appearance of horses and chariots often coincides with full desert conditions, reflecting new technologies for traversing an increasingly harsh landscape. By meticulously cataloging and dating these different layers of art, researchers can build a surprisingly precise timeline of environmental change, told not through sediment cores, but through the changing obsessions of the people who lived through it. This pattern of art mirroring environment repeats itself across the globe. In the canyons of the American Southwest, the petroglyphs carved by ancient Puebloan and ancestral Puebloan peoples tell a similar story of shifting worlds. Etched into the dark desert varnish of rock walls are images of animals that are conspicuously absent from the region today. There are detailed renderings of bighorn sheep, which still cling to existence in remote mountain ranges, but also more surprising figures like deer and even fish. Some panels show intricate spirals and patterns that may represent waterways or flowing rivers. These images are not random. They are concentrated in areas that geological surveys confirm were once near springs or seasonal streams. The art marks places that were not just spiritually significant, but literally vital, serving as permanent reminders of where water could be found and what life the land could support during wetter times. The precision of these animal depictions is particularly telling. These were not imagined creatures, but familiar parts of the artists' lives, recorded with the intimate knowledge of daily observation. What makes these artistic records so uniquely valuable is the human element they capture that other forms of evidence cannot. A sediment core can tell us the level of a prehistoric lake, and a fossilized bone can tell us an animal lived there, but only a painting can show us the relationship between the people and that world. We see the reverence for a powerful bull, the communal joy of a swim, the coordinated action of a hunt. This transforms cold data into a lived experience. It allows us to connect with these ancient individuals not as abstract concepts, but as sentient beings who celebrated beauty, faced challenges, and felt a deep connection to their environment. Their choice to spend precious time and effort creating art, often in difficult-to-reach places, underscores the profound importance of these images. They were likely a way to document their history, to pass on knowledge of animal migrations and water sources to future generations, and to perform rituals that they believed would ensure the continuation of the rain and the game. These galleries of rock art are therefore a powerful fusion of science and spirit. They provide climatologists with undeniable visual proof of greener conditions, and they offer all of us a poignant human connection to a vanished world. Standing before a painting of a swimmer in a cave now surrounded by endless sand is a haunting experience. It is a visceral reminder of the impermanence of our landscapes and the resilience of human memory. The artists could never have imagined us, their future audience, gazing upon their work millennia later. Yet through their hands and their pigments, they have granted us a priceless gift, the ability to see their world through their eyes, to share in their reality, and to understand that the barren desert we stand in was once a land of life, water, and wonder. When we think of forces that shape the desert, wind and sun usually come to mind, but there's another, far more violent architect at work, the volcano. These fiery giants don't just spew lava and ash, they completely rewrite the local water script, creating and destroying hydrological worlds in geologic instants. In deserts where water is already a precious and scarce commodity, volcanic activity can be a total game changer, capriciously granting the gift of new springs, or just as suddenly burying entire watersheds under a suffocating blanket of rock and dust. To see this powerful interplay in action, we can look to East Africa, a region where desert and volcano exist in close conversation. The volcanic highlands of Ethiopia, for instance, act as a vital water tower for the surrounding arid lowlands. But when one of these volcanoes erupts, the consequences are dramatic and direct. A massive lava flow can act like a natural dam, blocking a river valley and creating a brand new lake almost overnight. Conversely, a violent explosive eruption can blanket the landscape in a thick layer of water-repellent ash. When the next rain falls, instead of seeping into the ground to recharge aquifers, the water simply runs off the impermeable surface, causing devastating flash floods that carve through the dry soil and then vanish, leaving the land even drier than before. It's a paradox. The same event that brings water-repelling ash can also trigger catastrophic, yet useless, floods. The fingerprints of these fiery events are also etched into the landscape of the American Southwest. The Mojave Desert, for all its stillness today, has a violently volcanic past. Millions of years ago, eruptions sent vast rivers of molten basalt crawling across the land. As this lava cooled and solidified, it did more than just create the dramatic black mesas we see today. It fundamentally reshaped the desert's plumbing. These ancient flows diverted entire river systems, forcing them into new courses. In other places, the lava created natural barriers that trapped water behind them, forming temporary lakes that have long since evaporated. The evidence is still there for those who know how to read it. Geologists find mineral deposits like zeolites and clays that only form when hot water interacts with volcanic rock, proving that water was not just present, but was actively circulating through these fiery landscapes, creating a brief, steamy oasis in the midst of the forming desert. For scientists trying to piece together the timeline of these ancient events, volcanic ash is a gift from the deep past. When a volcano erupts catastrophically, it sends a unique fingerprint of glass shards and minerals high into the atmosphere, where winds can carry it across continents before it settles to the ground. In a desert environment, this layer of ash will be gently buried by sand and preserved with incredible integrity. Dr. Julie Rowland, a volcanologist, explains how these layers are like gold for paleoenvironmental studies. When researchers drill a sediment core from an ancient lakebed in the desert, finding a distinct ash layer is like finding a date stamp in the middle of a long, complicated book. Each volcanic eruption has a unique geochemical signature. By analyzing the composition of the ash in the lab, scientists can match it to a specific volcano and a known eruption date. instantly giving them an absolute age for that precise layer in the core. Everything above that ash is younger, everything below it is older. This allows them to date the fossils, pollen, and sediments with remarkable precision, correlating periods of wetness or dryness in the desert with specific moments in Earth's turbulent volcanic history. This intimate connection between fire and water forces us to expand our understanding of what shapes a desert. It's not just about long-term climate cycles or gradual orbital shifts. Sometimes it's about singular, catastrophic, and transformative events. A single eruption can create a new oasis that lasts for millennia, or it can snuff out an existing one in a matter of days. This geologic perspective adds a thrilling, explosive dimension to our exploration, reminding us that the story of water in the desert is written not only by the gentle fall of rain, but also by the violent fires from deep within the earth. Now let's venture into one of the most mind-bending transformations of all, the incredible truth that some of our planet's most arid deserts were once the very bottom of deep, ancient oceans. This isn't a metaphor, it's a geological reality. The story begins with the immense power of global ice ages, during periods known as glacial maxima, like the last one which peaked around 20,000 years ago. So much of the world's water was locked up in massive continental ice sheets that global sea levels plummeted by over 400 feet. Imagine that for a moment. Coastlines around the world advanced miles out from their current positions, exposing vast areas of the continental shelf that had been submerged for millions of years. As these shallow seafloors were thrust into the open air, they were subjected to a brutal new reality: scorching sun and relentless wind. The water that had covered them evaporated, leaving behind a thick, crystalline crust of salt and other minerals that had been dissolved in the ocean. This is the origin of the world's Great Salt Flats, or Sabkha's stunning, blindingly white plains that stretch to the horizon. They are not just dry lake beds, they are the literal, evaporated remnants of ancient seas, a chemical ghost of a vanished ocean. The evidence for this oceanic past is literally written in stone and in oil. Take the Arabian Desert, a landscape we now associate with sand dunes and oil rigs. The very existence of its vast petroleum reserves is a direct clue to its watery origin. Oil forms from the compressed remains of marine organisms, plankton, algae, and other sea life that settled in vast quantities on an oxygen-poor seafloor. The oil-rich strata underlying the sands of Saudi Arabia and its neighbors are the compressed, transformed sludge of the ancient Tethys Ocean, a vast body of water that once separated the supercontinents of Laurasia and Gondwana. The same sands that now blow across empty valleys are also filled with the fossilized remains of the creatures that swam in that ocean. Find a fossil in the Arabian Desert, and you're just as likely to pick up the spiral shell of an ammonite or the tooth of an ancient shark as you are to find a camel bone. These remains are not out of place, they are right at home, waiting for the wind to uncover them from their sandy tomb. Perhaps no desert on Earth tells this story more dramatically than the Atacama in Chile, the driest non-polar place on the planet. Its surreal landscape is coated in thick deposits of sodium nitrate, a highly soluble mineral that typically would be washed away by even a light rain. The fact that it exists here in such abundance is a paradox that points directly to a marine origin. The leading theory suggests that these nitrates were formed over millions of years from the droppings of seabirds, like guano, that fed on the incredibly rich fish stocks of the cold Humboldt Current offshore. This material, combined with ancient sea spray and other marine sediments, was lifted from the exposed seabed by the wind and deposited on the coastal plain. In a normal environment, rain would have dissolved these deposits and carried them back to the ocean long ago. but in the rainless Atacama, they have simply accumulated, creating a mineral crust that is both a record of past oceanic productivity and a key economic resource that was heavily mined for fertilizer and explosives in the 19th century. One of the most fascinating chapters in this story of revealed seafloors is the Persian Gulf. During the last ice age, with sea levels so much lower, the entire Gulf was a dry, fertile river valley, an extension of the Mesopotamian plain. The Tigris and Euphrates rivers joined into a single mighty waterway. Scholars sometimes call it the Gulf River, that flowed through this valley and emptied into the Indian Ocean at the Strait of Hormuz. This exposed land, known to scientists as the Gulf Oasis, was a refuge for plants, animals, and early humans. It provided a lush corridor for migration and settlement, potentially hosting some of the earliest populations outside of Africa. Then, as the Ice Age ended, the glaciers melted and the oceans rose. The water rushed back in, flooding the valley in a relatively rapid, geologically speaking, event known as the Flandrian Transgression. This inundation wasn't a biblical-style flood, but a steady, inexorable rise over centuries that would have been terrifyingly observable to the human communities living there, forcing a continuous retreat and forever submerging their ancestral lands. Today, sonar mapping of the Gulf's floor reveals the drowned world beneath the waves, the ancient river channels, lake basins, and even potential archaeological sites of those who once called this fertile plain their home. Scientists reconstruct these lost seascapes using a powerful combination of technologies. Sonar and seismic reflection profiling from ships map the topography of the seafloor, revealing the unmistakable contours of drowned river valleys and wave-cut terraces that are identical to those found on dry land. They then take core samples from the sediment layers beneath these deserts and offshore seabeds. These cores are like time machines. A core from the Persian Gulf might show a layer of terrestrial peat and freshwater snail shells from when it was a river valley, abruptly capped by a layer of marine sand and seashells, marking the exact moment the ocean returned. These local sea level changes are then correlated with the global record locked away in ice cores from Antarctica and Greenland. The ice cores contain tiny bubbles of ancient atmosphere and layers of dust that provide a precise timeline of global temperature and, by extension, ice volume. By matching the two records, researchers can create a stunningly accurate picture of how a specific desert was born from the retreat of the sea, linking a local geological event to a planetary climate cycle. These ocean-born deserts are the ultimate testament to Earth's restless, dynamic nature, reminding us that the ground beneath our feet is never permanent, but merely a snapshot in the long, incredible dance between land and water. There is a reason why the stark emptiness of a desert calls to us so profoundly, a pull that goes far beyond the search for resources or scientific discovery. This draw is rooted in something deeper within the human psyche, a fundamental yearning for the unknown and a powerful need to test our own limits against the most unforgiving of backdrops. Deserts, in their vast, silent majesty, are the perfect canvases for this inner exploration. They present a landscape stripped down to its essential elements: rock, sand, sky, and an immense, often brutal, openness. In the absence of distraction, we are left alone with ourselves, and it is in that profound solitude that the desert works its transformative magic. Explorers throughout history have attested to this effect. T.E. Lawrence, who became Lawrence of Arabia, did not just navigate the deserts of the Hejaz, he was fundamentally reshaped by them. He wrote of the desert's clean and mathematical purity, a place where the complexities of modern life fall away to reveal more elemental truths about endurance, resilience, and one's own character. Modern archaeologists and adventurers echo this sentiment, describing expeditions not just as journeys across land, but as voyages into the self, where the physical challenge of surviving the heat and thirst is inextricably linked to a psychological recalibration. This powerful attraction is fueled by a combination of compelling motivational factors. There is, of course, the powerful allure of the historical puzzle, the detective story written in stone and sand. The chance to be the first person in millennia to lay eyes on a lost city, to hold a tool last used by a forgotten hand, or to finally solve a mystery that has baffled scholars for generations, is an irresistible siren call for many. It is the thrill of connecting the dots of our collective human story, of pulling a narrative thread that seemed forever lost. Yet running parallel to this intellectual pursuit is a more spiritual quest. The desert has long been a place of revelation and retreat for prophets, mystics, and seekers. The very austerity of the environment seems to facilitate introspection. Without the constant noise and clutter of civilization, the mind can quiet down, allowing for a clarity of thought and a focus that is harder to achieve anywhere else. In the immense silence under a canopy of endless stars, one cannot help but contemplate their place in the universe, fostering a sense of both humility and connection to something vast and timeless. Psychologists like Dr. John Rich have studied this phenomenon, noting how deserts consistently function as powerful metaphors in our literature, art, and film. They are the ultimate symbolic landscapes for struggle, purification, and rebirth. From the trials of the Israelites in the wilderness to the visionary journeys in Frank Herbert's Dune, the desert represents a crucible where the hero is tested and emerges fundamentally changed. It is a stage for the ultimate showdown between the human spirit and an indifferent universe. This metaphorical power resonates because it mirrors a universal human experience, the feeling of being lost, parched, and tested in our own lives, and the hope that we too can find our way to an oasis of understanding and emerge stronger. The desert, therefore, captivates us not in spite of its barrenness, but because of it. Its emptiness is not a void, but a space full of potential for discovery, for insight, and for personal transformation. It is a mirror held up to our own souls, reflecting back both our fragility and our incredible capacity for endurance, reminding us that the most important worlds we can ever discover are often the ones hidden within ourselves. But as we pull back the sand to reveal these astonishing watery pasts, a critical and urgent question emerges. Now that we know these secrets, what is our responsibility to protect them? The very act of discovery brings with it a profound ethical duty, a need to balance our thirst for knowledge with a commitment to preservation. This isn't just about safeguarding ruins or artifacts. It's about protecting an entire heritage of water, a legacy of life that is incredibly fragile and non-renewable. A growing global movement recognizes that these desert landscapes are not just open-air museums to be studied, but sacred archives to be cherished, requiring a careful blend of international oversight and local stewardship to ensure they survive for centuries to come. One of the most powerful tools in this effort is the prestige and protection of a UNESCO World Heritage designation. Sites like the Tassili Ennaja Plateau in Algeria, a vast lunar landscape of eroded sandstone, are celebrated not just for their breathtaking natural beauty, but for being one of the most important collections of prehistoric rock art on Earth. These ancient paintings and engravings are the library of the Green Sahara, depicting the rivers, lakes, and animals that once thrived there. The UNESCO listing acts as a shield, helping to marshal resources against modern threats like vandalism, uncontrolled tourism, and the creeping damage of climate change. It elevates the site from a local treasure to a responsibility shared by all of humanity, creating a framework for managed access, scientific study, and conservation that prioritizes long-term preservation over short-term gain. Yet, preserving this heritage goes far beyond protecting static art on a rock wall. It involves reviving the very wisdom that allowed ancient cultures to thrive in these environments. In the arid lands of Namibia, where rainfall is sporadic and precious, community-based projects are looking backward to move forward. They are resurrecting ancient water harvesting techniques, building modern versions of traditional systems to capture every possible drop. This involves constructing simple, clever earthworks, contour trenches, and low stone walls that slow down the flow of rainwater during rare storms, allowing it to seep into the ground and recharge the local aquifer instead of washing away. This isn't high-tech engineering. It's applied ancient knowledge, and it empowers local communities to take control of their water security, reducing their dependence on scarce and often distant government sources. By valuing this inherited wisdom, they are not just conserving water, they are actively preserving a living cultural practice, a direct link to the ingenuity of their ancestors. The mission to protect this legacy also extends to the living relics of those greener times, the species that cling to existence as reminders of a lost world. Organizations like the Sahara Conservation Fund undertake this vital work, focusing on creatures that are perfectly adapted to arid life now, but whose ancestors roamed a much wetter landscape. The majestic Addax antelope, a beautiful white antelope with magnificent spiraling horns, is a perfect example. This creature is a true desert specialist, capable of surviving for nearly its entire life without drinking free water, deriving moisture from the plants it eats. Yet it is critically endangered, its populations decimated by hunting, habitat loss, and climate change. Protecting the Addax isn't just about saving a single species, it's about preserving a unique thread in the web of life, a living testament to the incredible adaptability that life developed in the face of the desert's advance. Their survival is a barometer for the health of the entire ecosystem they represent. Underpinning all of these efforts is a fundamental shift in philosophy, championed by experts across the field. The principle that effective, lasting conservation cannot be imposed from the outside. It must be woven into the fabric of the local communities who have called these deserts home for generations. This means moving beyond seeing people as a threat to the environment and instead recognizing them as its most crucial partners. Successful projects are those that actively involve indigenous knowledge, hire and train local people as rangers and guides, and ensure that the economic benefits of preservation, through responsible tourism and sustainable practices, are shared fairly. When a community sees a direct connection between protecting an ancient rock art site and putting food on their tables, or between reviving a water harvesting technique and the health of their livestock, their investment in the outcome becomes personal and powerful. This collaborative model transforms conservation from a restriction into a shared value, a common purpose that honors both the deep history of the land and the people who are its present-day guardians. From the sprawling green savannas of the ancient Sahara to the vanished lake networks of the Arabian Peninsula, our journey has revealed a truth far more incredible than any fiction. The world's great deserts are not empty, barren wastelands. They are dynamic, ever-changing landscapes wearing a brilliant disguise, each grain of sand holding within it a story of profound transformation. We've walked alongside the ghosts of hippos in now dry riverbeds, marveled at satellite images that see through sand to map lost waterways, and stood in caves where ancient artists painted scenes of swimming and abundance in a land that now knows only thirst. These are not isolated curiosities, they are powerful, interconnected pieces of evidence pointing to a planet in constant, dramatic flux. These hidden, watery pasts are more than just fascinating historical mysteries. They are essential lessons etched into the very fabric of our world. They teach us about Earth's incredible resilience, its ability to swing between lush green and arid gold in rhythms dictated by the subtlest shifts in orbit and atmosphere. They showcase the breathtaking ingenuity of ancient civilizations like the Garamantes and Nabateans, who didn't just survive in a changing world, but thrived by mastering the art of harnessing water, offering us timeless strategies for sustainability. Most critically, these desert archives provide us with a long-term perspective on climate change, documenting the stark realities of environmental volatility and the dire consequences for societies that fail to adapt. This deep-time view urges us to shift our perception completely, to see deserts not as voids on the map, but as the planet's most meticulous libraries, storing the records of past climates in their geology, their fossils, and even their folklore. As we face our own era of unprecedented global environmental challenges, these lessons have never been more vital. The stories buried beneath the dunes are not relics of a distant past. They are an urgent, relevant guide for our future. They inspire us to protect these fragile landscapes and the secrets they hold, to manage our precious water resources with wisdom rather than waste, and to approach the natural world with a sense of humility and awe. Let these hidden worlds be a catalyst for curiosity and a call to action. I would love to hear which desert mystery captured your imagination the most. Was it the lost city of Yuba, swallowed by the sands, or the incredible migration of early humans across a green Arabia? Share your thoughts in the comments below, and if you enjoyed this deep dive into Earth's forgotten chapters, please subscribe and turn on notifications so you don't miss our next adventure into the unknown. The next time you find yourself looking at a vast, dry landscape, remember, you might just be standing on the bed of an ancient ocean, walking over the ruins of a lost civilization, or tracing the shore of a lake that vanished millennia ago. It is a powerful reminder that in nature, nothing is ever as simple or as empty as it seems. If this journey through the desert's hidden, watery depths has sparked your sense of wonder, you can help keep that spirit of exploration alive right here. Liking this video is a fantastic way to show your support, and sharing it with anyone who loves a good historical mystery helps our entire community grow. Make sure you don't miss our next adventure into the past by hitting that subscribe button and tapping the bell to turn on notifications. We're always digging up new stories, and you'll be the first to know. I'm truly curious to hear what you think, so please drop a comment below and tell me which desert mystery we should uncover next. Are you drawn to the silent, shifting secrets of the go-by, or perhaps the ancient, sun-baked enigmas of the Australian outback? Your thoughts and suggestions directly inspire what we explore next, and your engagement is what allows us to continue bringing these incredible stories to the surface. From the bottom of my heart, thank you for watching, for your curiosity, and for joining me on this remarkable journey. Never stop asking questions and never stop looking.